Thanks for everyone attending our Studio Mapper webinar today. My name is Lawrence Cronje. I'm a geologist at Datamine Africa. And today I'm very excited to share with you a brand new solution in geological face mapping, namely Studio Mapper. So again, if anyone is unable to hear me clearly or see the screen, please just submit a question. And let's try and keep it interactive. Submit some questions on the side and I'll try and get to them as we go on. I'm going to follow a slightly different approach today. I've opted to record a video of the webinar prior to this in order to focus on the speaking. Reason for this is that our time is quite limited and there's quite a lot I would like to show, which would not have been possible if I had to do everything manually. So some of the boring parts of the video are sped up just to save time. But I've got the software open here. If you have any questions, we can open it up and display anything additional you may want to see. So let's get started. Just a bit of history on the product. Our first public release of Studio Mapper was earlier this month. So the product is still fairly infant. And most of the development is being guided by proof of concept studies that we are conducting with clients around the world. It's for us to allow us to get the software into the hands of production guys early on to ensure that the solution is practically driven. And it's by no means finished. We are spending a lot of resources to include some additional features, make the tool better. But there's a lot of people that are using it in its current form. Okay, so first thing you will notice, some of our users that are familiar with Studio, you'll see there's a lot of similarities, although we've opted for a bit more of a simplified interface. The software is designed for both a desktop and a tablet platform. So you'll see that these buttons are quite enlarged to make the use of tablets easier. You can load all your reference data. So I've got some drill holes loaded in here, some CAD data. I've got a few ore wireframes loaded. And of course, these don't need to be in native Datamine format. And one can, there's data source drivers to bring in external data as well. Okay, so the software is completely configurable. In the setup ribbon over here, you can see that we have a database directory, and then we have what's called the configuration file. So the configuration file is where we set up all the formatting, your drop-down list, the reef codes. It's all done in the background so that you as a user can only focus on capturing the data at the face. Now, before you start your mapping for the day, you would come to this portion over here. You would specify the current area that you're working in, and this will inform what the naming conventions will be and what data is loaded, all the reference data such as your holes and the development drives. So here I've already created a few maps, and I want to take you guys through a typical workflow that a production geologist would follow with a routine mapping exercise. And take note, this is only one way in which we can approach this task. There's few ways. So you can see here we've got some hatching and going around that tunnel. So as some of you would know, is that usually in an active production environment, at an active phase, you may not have sufficient survey data available, and you may want to lay down some tapes and measure the distance to the face from a known location, such as a survey station. So here I have got a fake survey station, P160, and I'm going to lay down basically a virtual tape with a measurement that I took and an azimuth. So I specify the location from which I measured, which is this P160. You can also manually type in the X, Y, Z coordinates if you like. And then we add our measurements. In this case, a distance of 5 meters at an azimuth of 321. And now we have our new known location, right? So this is basically just a virtual representation of what gets done. So now we move over to this mapping ribbon here, and I'm going to create a new map. This name is based again on the date. You can set this up in your configuration document if you want to include, let's say, the level or the area or the shaft. And then we also have a few different map types, and this will depend on what you want to include. Do you want to include the sidewalls, the roof and floor? So for this example, let's do a full heading where we include the face, sidewalls, and the roof. And then you specify the dimensions, the width, height, and depth of your map. Okay, so what this is going to give you is basically a blank sheet. You can think about this almost as if it's your field book, right? So we've got 4 planes representing each side, and right now we are focusing on the front. So typically what a lot of the guys would want to do is to include a profile. So you can have some predefined profiles. I've included one here that defines my tunnel. You can see here with a width of 3.5 and a height of 4.5. Again, you can add as many as you want, and you can customize it as to your preference. Okay, so I'm going to add the profile, and there it gives us almost a sort of drawing boundary. You can edit this or free draw on top of it as well if you would like to make some edits. Then in the next tool over here, or the next tab rather, you can add photographs, which I'll get back to later. A lot of the clients opt to go that route. And then the next tab is where we add our geological structural features. Now I just added some demo features over here, polygons, structures. So let's add a linear structural feature, for instance. And again, you can think about this as if it's your field book. And as soon as you're finished drawing it, we'll see there's a new record that's listed over there. And these columns, again, are set up in the configuration file. I've just added some commonly encountered ones like fault type, depth direction, displacement. And you can do some measurements on the screen as well. So there I can measure the dip, which is 77. It just takes an average of the string. And in future, we will be adding some structural symbols that show you the throw and whether it's left lateral, etc. You can also make changes to the string afterwards. All your like CAD tools, your string tools that are available in other Datamine products are available in here as well. Okay. So for the next one, let's add a polygonal tool. Again, there's some new drawing features we've added, like this free draw tool, which is really nice on a stylus if you're using a tablet to do your mapping. So you can see the hatching is already applied. And as soon as we're done drawing it, a new record is entered there, and we can specify, let's say that is a dike. And you can add some more parameters, as much metadata as you like. Grain size, alteration, and I had a little comment box. All right, let's add another polygon. What's important is the auto snap mode. So this allows you that you don't have to snap to each and every single point. It recognizes the string, and if you have features that are sharing a mutual boundary, it automatically snaps to the entire line, which of course saves a ton of time. Okay, I'm just going to fast forward this a bit. Again, you just snap to the abutting boundary, specify the reef code, and your hatching is applied. All fairly simple. Again, the big buttons at the top allow you for the tablet usage. Okay, so now I'm just adding some more data just to fill it up. Okay, so once you're done with, let's say, your face, and you want to start moving over to the sidewalls, you simply choose here at the top. Let's say you want to choose the right sidewall. Then the window automatically aligns with that sidewall and the grid gets placed on top of it. Right? Now for this example, I want to show you how we can add some photographs, which a lot of the clients are doing. So we simply choose where our photograph is stored, excuse the stock image, didn't want to use a client's data. And now once you've added the picture, you can move it around, you can rotate it or resize it. Okay, so let's say the next step, you want to add some geological features to it. Again, we can either add polygonal or linear features on top of it. Typically for top and bottom contacts in a vein or reef-like situation, you would want to use linear strings as well, because at the end of the day, you want to use these strings to update your ore wireframes, which is what I'll show at the end of this webinar. So in this instance, I specify my top contact as well as my bottom contact. And at a later stage, we will export these strings and then use them to update those wireframes. So then typically you also want to add some polygons in between, just for aesthetic purposes or when you're creating your reports. And I think it looks quite nice if you have the image in the back with this transparent hatching sort of superimposed on top of it. Okay, so I'll just fast forward through this again. You get the idea. Now, of course, that doesn't really make a lot of geological sense. In actual fact, on a real world scenario, you would obviously want to snap to the face what you're drawing on the sidewalls. So in this instance, I can go and snap on that boundary over there, align my screen, and continue drawing the polygons in here. And of course, that'll be similar reef type to the one seen in the face. Okay, I'm just going to fast forward a bit. And then finally, maybe I would like to add something in my roof. This structure that cuts through there, I'm going to add it in plan as well. Okay, so once we're done inserting all our geological features, we have to georeference this into the correct 3D space. So if you remember that we already created that known location point with our tape measure, and now you have to specify the position on the face to which you measured, right? So this point over there, where does it correspond with on your 2D unregistered image, right? So we go to our Georeference tab. You can either specify georeferencing it by 1 or 2 points. In this instance, we're just going to use 1 point. And you specify the shot point on the face, which is somewhere here in the middle. And then you can either manually type in the XYZs or simply snap to that known location that you projected. And it will bring it into your 3D environment. So now, as you can see, our azimuth of the map is still wrong. So we can use this rotate tool just to get the azimuth correct. Make sure the correct map is active. Choose rotate and use the orbiting tool just to align it with your drive. Okay, and then again, that doesn't make a lot of geological sense, but we got something now in 3D space. So just something I quickly want to touch on is sampling. So at the moment, due for our next release, we are busy implementing sampling functionality to capture phase samples in here. So this is a prototype of what we're working at. You'll be able to capture the samples at the face and then add your QA/QC samples such as your standards, your duplicates. The naming convention again will be specified based on your current map and working area. Yeah, I just see there's a question that came in. Okay, I think everyone's got it sorted. So that's due for the next release coming out in the coming months. I just thought I'd mention it quickly while we were busy with that portion. Okay, the next thing I want to touch on is how one can generate quick and easy reports from this data. So there's two options. The first is to generate this, what you call 3D PDFs. So these are really handy, especially if you want to share the data with people who do not perhaps have the software, maybe colleagues or clients. So you simply click on this 3D PDF option, hit OK, and most good readers that have a 3D function should be able to display it. I have Adobe, and it outputs something like this. So you can see that some of the hatching and the formatting gets lost, but you definitely get an idea of the mapping that's been done. Then the other option is the automated PDF report. Again, this is completely customizable. I just set up a quick report here in my plots window. It's not the most aesthetically pleasing plot, I'm embarrassed to say, but I can just show you how easy it is to just generate a quick report from that map we just drew. So I hit PDF report, and then the map, the name will be based on our level and our working area. And then we have something like this with our 4 faces that we mapped and sidewalls. And then here at the bottom, once our sampling functionality is in, you could list the sample IDs together with the froms and tos. And an important thing to note is that we are also building an API so that you can upload those samples to your GDMS directly from Studio Mapper. Okay, so the next portion I'd like to show you guys is another scenario where we have some maps that represent more like of a stoping environment. Oh, sorry, I first want to show you that you are still able to edit these maps after they've been georeferenced, right? You can either do it in 3D, like I'm showing now, or you could go back to the 2D environment by simply choosing your map, saying view map. It takes you back to a 2D environment, and you can make changes here and it will dynamically link to 3D. You can add some free sketches. I forgot to mention this. So similarly to your notebook, you could just add some free drawing. Maybe you have some observations that you'd like to show on the report. And then you are also able to add comments. That can be displayed. So let's say, for instance, I think in this example, I add a comment that there is some overbreak in the roof here, and you can specify color for your text. And if I go back to my 3D window, you'll see that it's dynamically linked. The comment is now showing on that map face over there, as well as my sketches. Okay, so the next step, I'd like to show you where we have a bunch of maps where we've, like you can see, this is more elongated maps. Let's say, for instance, that black polygon over there represents our reef. I'm going to load our all wireframes. So I just want to put it in section. So you can see the red is representing our top contact and the green our bottom contact. And you can see that the mapped polygon does not exactly follow the modeled top contact. So now one can actually go and export these top and bottom contacts, take it to your modeling package, and dynamically go and update the wireframe. So now I'm gonna show you this export tool. So we go to Data, Export, and what this will do is you specify your working area, you specify what type of data you'd like to export, as well as a date range. So let's say once a week you do an export, you make a folder on the central server where everyone has access to it. Let's say the resource geos want access to the newly mapped strings every now and then to update their wireframes. So this is how the table would look like that you exported now. I've got my reef contact.dm file. There's XYZ coordinates for the contacts, and then all the metadata that you captured as well. Your grain size, the mine, the area. Like I said, all of the records will have date stamps on them as well. And then of course your reef code. So yeah, I've got UG2 hanging wall and footwall. And what I'm gonna do is I'm gonna import this reef contact file into StudioRM, which is Datamine's modeling package, but you could load this into other modeling packages as well. Let me just add the file, reef contact, and show you how I can now dynamically go and update the OR wireframe using those exported strings. Okay, so the string at the top represents our hanging wall, and then in this instance I'm only doing the hanging wall, so I'm using the new vein modeling functionality in StudioRM. I'm going to use the reef contact string, add them as additional hanging wall points, and then recompute the surface. And as you can see there, now we have a new surface that follows the trend of those points. And if I go through the section, one can see that it now snaps to those strings. So it's a really quick way of going from your mapping data to your modeling data, just in a few brief steps. Okay, another thing I thought might be useful, like I said, a big advantage of this tool is the fact that one can have all the reference data available to you, right? So your drill holes, your block models, etc. You can map knowing what was intersected with a drill hole right next to you or a few meters away. So let's say in this example, I have a few faults here in plan, and I would like to project them down to see where we might expect to intersect them at the level below. Right, so I'm going to use this tool called extrude strings. I calculated my dip and dip direction of the fault, and I'm going to create a new wireframe projecting them down. So I create a new object, call it fault projected, specify my azimuth, or in this case dip direction, and my dip, and let's extrude it 150 meters down. Okay, so now it's extruded this wireframe over here, and here at the level below, I can now use my measuring tool to see when we might expect to intersect this fault. Let's say 4 or 5 blasts from now, and we can be prepared for that. Okay, so I think that's just a very quick overview of some of the basic features in Studio Mapper. I think we should have a little Q&A session now, perhaps. We still have some time left. Otherwise, I'll share it now. Feel free to mail me anytime. I'll be happy to show you guys some additional stuff. There's my email address. Please feel free to reach out.